morning. My name is Hyung-Sik Kim from University. In this presentation, I will just introduce radio and electromagnetic method to for making video interface. This presentation consists of three sections, and in the second section, I will explain our three approach mechanisms based on this radio and electromagnetic methods. And last section, I will compare and challenges of these two methods. There are two strategies to produce haptic feedback on contact and non-contact manner. And I think everyone here will know about what is the video haptics. So there are two representative research and ultrasound, and based on ultrasound and compressed air. And they have already have a prototype and have many applications, and they developing their application and demonstrating haptic related components every year. And they are trying to their application into the vehicle and Bosch company, and also the BMW try to equip and utilize their ultrasound application in their vehicle, and the digital lab is used the compressed air and comprised with the express console. And I did compare this to actuation source and this intensity. This is relatively comparison for our radio and electromagnetic based. And intensity is controllable and not controllable. Actually, compressed air controllable, but the controllable range is already small, so we define that it's not controllable. And spatial resolution, two of them are all low, and system dimensions are a little bit small, and working distance is ultrasound. Their papers effectively transport their ultrasound to feel the tactile sensation about 30 centimeters, and compressed air about now is 1 meter. So sometimes 1 meter is enough, but someone is not think 1 meter is not enough. And these two methods also have a working noise. This means when some energies flew out into the air, or with the working sound, ultrasound has a noisy, noisy sound continuously. And system complexity is medium complex, and cost is two of them are low cost. So our research team has three motivations. First is enhanced spatial and time resolution, and secondly is prolonged working distance. Some is one method is enough, but I don't think it's one method is not enough, because when you are standing in front of the TV to play a game, one method is very close, and we want to stand in front of the TV. So we want to prolong the working distance, and number three is not realized yet, but we hope to reach a high functional tactile sensation. This high functional means warm, hot with some of the other tactile sensation, like touching your clothes and touching the button, right? Touching the button. And so one of our approaching mechanisms is the radio, and it's somewhat elastic effect. Everyone knows the radio, what is the radio. So this is working, and this is radio pointer, and this is output type is continuous wave radio. So, and the other thing, emitting method is first output, and when the continuous output is related on the human skin, so only human feel the hot and warm feelings, and our approach is use the pulsed output ratios. When we use the pulsed output, very short pulse with range under the nanosecond region, and use the very high radio energies. This when we use it related on the human skin, there is some physical phenomenon that is somewhat elastic extension, And from the thermal elastic expansions, we can make a stress wave on its medium. So the stress wave, humans feel the stress wave as a tactile sensation, like mechanical tap. So this is possible because the first laser only increase dramatically, instantaneously increase their medium rate, temperature in region and dramatically down their medium temperature and also the radiation frequency. We control the radiation frequency. The some temperature rise does not increase. So we can make and release mechanical tap. This is illustration of our laser system. Professor Sun drew this figure, and we used the 532 nanometer lasers. That is green visible lasers, and we used the red coated tape and white tape as a medium, and where the reason why the red coated is complementary color of green laser and to efficiently observe the optics energy and be converted to mechanical stress wave. And white tape is just for protecting the human skin. This is rest wave here, and we also this is our medium, and rightmost figure shows our rest medium, and we also build up the measurement setup with the PVD sensors, and the laser is normally related to the medium, and we check the cross and the plus and minus sign means push and pull back of the medium. So the wave is right here, and we also simulate the result, action and radial condition, and we superimpose these two results. We can draw a graph of the mechanical wave. The rightmost figure shows that. And we also did the human perceptual experiments, like this. This is our system, optical set of laser system is here. Optical system is between human hand and laser system. We use the two laser mirrors and optical filters to drop down the laser energies and ranges here, and indexing human hand is right here. So we also gathering data from the mechanical wave and thermal stimulation, because to compare this laser stimulation and the mechanical, and this is the human brain signals from the electroencephalography, and mechanical wave, the wave is here, and non-painful laser is a little bit similar tendencies. So, and the human record there feel it as a mechanical tap. And second, our approach is laser and its plasma phenomenon. That is plasma maybe everyone knows, and we change the laser system to individual lasers, 1064 nanometer wavelengths, and we will use the more shorter power, shorter pulse width, and with more higher laser energy. So when we use this system, we can make plasmas in the air. When the plasmas formatted in the air, there are four physical phenomena can concurrently occur. And so these are physical phenomena: pressure, sound, shock wave, and electric field. So we use these four and shock wave as a source of the mechanical tactile sensation, and pressure is used for making an image in the air. So this is our plasma-based approach, and laser unit is here, and 2D positioning unit is here to 2D positioning. 2D scanner is used here to making a simple image in the air. This is our setup. Laser system is here, and the laser traveling or ray is here like that, and range is here, and the plasma is formatted here. The distance is not constant because the razor theoretically the working distance is not unlimited. That is dependent on the human range. So this is our overall setup, and this setup controlled by one computer. And this is image result. We did make image in the air with the plasma. Some Japanese group already done, but they are very big images in the air. But I'm small, because some companies want to just make a button in the air. That is, so, and we make just 1 centimeter, and camera sampling problem that is comfort. This picture shows that is consists of point, but in real environment that is fully shaped with the line, and finally we made. And we also measure the mechanical shock wave, and how much is the shock wave generated. So we use the two measurement devices, accelerometer and microphones here, and plasma is formatted this time, zero time, and after 300 microseconds, these two sensors are response, and the response is 400 microseconds. Is 300 microseconds is traveling time through the air. And we also did human experiment like here, and we used the Faraday cage because the plasma generates also the electric field. The electric field is induced the human brain signal, so we use the Faraday cage, and we also use the black capable to block the flash light from the plasma, and we also use the headphone because the plasma-based method has also working ways. And the result is here. In conclusion, some of people can feel that is mechanical depth, some is not electrostatic feeling. And another approach is based on magnetic field. That this approach is a little bit different other two with the haptic interface. Ultrasound, laser, and compressed air is kind of some energy, throw some energy into the air. But this is not throw some energy. This is used the fundamental mechanism is mutually induce some electrical energy into the human body. So this is schematic, because that is possible because all human bodies are controlled by a small electric signal. This small electric signal individually they hold that is our action potential. So this small signal we can manually make outside from the body. So we use the electric coil here, and we inject some electrical energy to the air. The electric coil make a magnetic field concurrently induce current is induce current in the human body. And interesting thing of this mechanism, this approach is even on object is rated between human hand and stimulation capacitor in this coil. This method can deliver some energy, and another with the haptics is not possible because some energy is blocked from object. And now I equipped it on the desk, back side of the desk, and I feel the sensation. This is our prototype system, very big system, and now we have saw the prototype, and the size is decreased to half compared this, And in the first prototype, the stimulation coil is submerged into the water because the electric coil has increased their temperature because this system is used very high power to generate magnetic field and induce the current transmission potential. And we did also human experiment. People, subject is inside here, and we also use Faraday cage because it used the magnetic field, and human hand is here. And we also object test, and this is the object is air, and this is wood and compressed paper, and ordinary box, paper box, and acrylic plate, and paper and books. And all of these are, if the object is not a non-metallic object, then all the people can feel the sensation from the electromagnetics. And this is evidence. Someone is how we can feel the electromagnetics. That is, this is evidence. We are gathering phase signals, and we analyze ERT waveform. And we did 3 intensities: low, medium, high, and 4 frequencies. That all parameters we can check the phase signals, and 100 and P300. And we also frequency. We did also frequency response mechanical techniques here, and the wave shape is right here. And one single magnetic field. This is not a hertz, and one single magnetic stimulation, and this wave is similar tendency. And this is the compare and challenges in laser and magnetic method. Laser method has a major drawbacks on the human eyes is very hard to make a laser and someone and skin deformation. My hand is deformed because this research, and now the industrial the laser system is very expensive. And magnetic field and drawback is basically use the electromagnetic phenomenon that it generates EMI. This is electromagnetic interference to the other electronics. But now and our subjects is not necessarily working well until now, and potentially it is electrical hazardous because it used over 1 kilovolt and over around 300 amperes, so a little bit dangerous. But these 2 drawbacks can overcome. And I hope to, and my final point is here. This is program, and first is we would like to raise someone knows this figure, and some researchers, Dr. Hojinli, knows this figure, and I try to do this and to realize this figure, and I also looking for another approaches to realize this, and combination and